All right, in this video, we're going to be covering concavity and points of inflection, okay? It's a very important skill to have, not just for this packet, but for the entire exam, okay? Understanding how graph analysis works. So here's a quick refresher before we actually go towards the problems. Obviously, if you know this part, you could skip this part here, okay? But way back when, I had you guys write some statements, okay? If something happens, something else happens. If something happens, something else happens. And I'll give you a hint. This is in regards to either f, f prime, or f double prime, okay? If something happens, then something else happens. Okay? And what else did I have? Oh, okay. There were multiple implications of this next part. So there are 3 different statements that meant the same thing. Hopefully I didn't forget any of it. So if something happens, then something happens. There are 3 different lines here. Okay. Feel free to go back to your notes if you need to. But I'm going to go ahead and start here. And if you feel like you remember it, pause me and then finish the rest, okay? So here we go. For instance, we know that a function f is increasing if and only if. That would imply that its derivative is positive. Okay, so if that rings a bell, pause the video here and then fill out the rest because you want to see what you can retain, okay? All right. If f is decreasing, then that would imply that the derivative came out negative. The slope of the tangent line was negative, okay? And if something happens, then f has a local max. And if something happens, f has a local minimum. I guess I'll draw some lines there. Okay, so remember that if f prime changes from positive to negative, then you have a local max. F has a local max. F prime changes from negative to positive, then there's a local min. Okay? So here, oh, I knew I forgot something. Okay, let me scoot this down a little bit. Okay. Okay, so here, I'll start it off for you. F is concave up. Okay, again, pause where you need to. Press play when you're ready. If f is concave up, you know that the second derivative is positive. If you know that the second derivative is positive, that would imply that the first derivative is increasing. Okay, that tends to be the part that most people forget. Make sure that you make an effort to know all 3, okay? So if f is concave down, then that means the second derivative is negative, which would imply that the derivative is decreasing. You have to remember, you won't have these on your exam. You kind of have to remember it, okay? So make sure that you practice. So if something happens, then f has a point of inflection, okay? Or an inflection point, or POI in short, okay? So if you take a look here, f has a point of inflection when f changes concavity. So notice here, when concavity changes for f, you have a point of inflection. what does that mean with f prime? So take a look at f prime. What's changing here? Okay, f prime is changing directions. Okay, so what does that mean with f double prime? Take a look here. What is it really changing? F double prime is changing signs. Okay? Be very specific about what you talk about. Okay? Don't say it. Say either f prime, or f double prime. Be very specific. This goes back to when you guys did that Flipgrid video where you had to kind of switch hats. You had to change the language, okay? If they're speaking one language, you got to translate it to see what they're really asking you for, okay? Okay, so let's go ahead and take a look at the concavity and points of inflection problems. All right, so here is our first problem in 2011, part C. We're talking about a point of inflection here. So what you want to pay attention to is they're referring to a specific function. In this case, they're asking us for where the graph of G has a point of inflection. Okay, so instinctively, when you think of points of inflection or concavity, you want to get straight to the second derivative for the most part. Okay, so we know that from the previous problem, g of x was 2x plus the integral of f from 0 to x. And then we found out that the derivative came out to 2 plus f of x. So the second derivative is really just f prime of x. Okay? So g double prime will behave just like f prime. Okay? So if g double prime changes signs, f prime will also change signs. Okay? So if g double prime is positive, f prime is also positive. Okay? So here, f prime, right? How do we get information on f prime? So we know that f prime will be positive. We know that f prime is positive if f is increasing, right? So we have to translate according to the picture that we have, okay? So if you take a look at the graph here, we have the graph of f. So we have to translate all of this, all right? So I know that f is increasing. According to my picture, f is increasing from negative 4 all the way up until 0. So just to kind of illustrate that, it's increasing, f is increasing all the way up until 0, okay? And then notice that right after, from 0 onto 3, f prime is actually negative because f is decreasing, okay? So remember, G has a point of inflection if G double prime changes signs. And since G double prime is the same thing as F prime changes signs where? Okay, here F prime changes signs at 0. Okay, so right at 0 is where F prime changes signs. So you would say, it says find all values of x, so you would say x equals 0. But here's the part, and here's where you're going to be asked to do a lot of, okay? Give a reason for your answer. So just like your Flipgrid videos, you have to justify it. Since G double prime is equal to F prime, changes signs. And that's it. Okay? If you take a look at the scoring guidelines, I'm sure they'll give you a more lengthy answer, but let's take a look. In part C, if I can find that question. I think it was this one, yeah. Part C, it was an easy one-pointer, okay? Usually they give you more, but you know, they wrote something different. But what we have over here will suffice, okay? All right, let's do a couple more. So, okay. This one here is more analytical. The reason why I know that is because we're not given a graph, okay? So, in the previous problem, we remember that, I'll write it over here. F prime is 4 minus x times x to the negative 3. What we're going to do is we need to find all the intervals where f is concave down. So again, when you talk about concavity, generally you want to get to the second derivative here, okay? Now, you could do two things here. You know, the way that it's set up, it looks like a product, okay? And you could use the product rule, but I'm just going to go ahead and distribute this first. I'm going to distribute the x to the negative 3, kind of like how I did in the previous part. So this will be 4x to the negative 3 minus x to the negative 2, okay? If you're not sure how I got that, just let me know. So from here, the second derivative will be negative 12x to the negative 4 plus 2x to the negative 3. Okay? So this is where we got to rewrite this a little bit. Negative 12 over x to the 4th plus 2 over x cubed. All right? We want to find out where the second derivative is 0 so that we can create some type of sign chart here. Okay? So before I do that, I'm going to go ahead and make one big fraction. So I'm going to try to get a common denominator here. So that'll give me a common denominator of x to the 4th. And up top will be negative 12 plus the 2x. Okay. I'm going to set this guy equal to 0. All right. So more on the analytical side. In order to make a fraction equal to 0, you have to make the top, the numerator, equal to 0. Okay? So if you solve this here, x should come out to 6. Now, that's not enough to show that that is, you know, the point of inflection or, you know, where it's going to be concave up or down. We actually have to check. So here we go. This is for our second derivative. We know that at 6, that is a value where the second derivative is 0. We call that a PIP, possible inflection point. You don't want to call it a critical value because that's different. So you test it. So an easy number, I'll pick 1 and 7. Okay? And we're going to plug it into up here. So notice how in the denominator, no matter what happens, if you raise it to the 4th power, the denominator will always be positive. So really it's based on what's happening up top. Okay? Negative 12 plus 2 times 1 will give you something negative. Okay? If you plug in 7, that'll give you something positive. So where's it concave down? Pretty much everywhere here. Okay? I got to emphasize to you guys, the sign chart is not enough to get the points. It's really your conclusion and your understanding of it. So we're going to say everything that's less than 6, okay? So when x is less than 6, okay? Now here they mentioned that x has to be greater than 0, so you could definitely revise this. I would say from 0 to 6, f is concave down, okay? How do you know that? And this is probably the most important piece. Since, how do we know that? F double prime is less than 0. Boom, that's it. Okay? If you take a look at the scoring guideline, it's important that you know how they grade you because that gives you an idea of where the points are, okay? Where are we? Oh, okay. So we're right here. So if you take a look, they did a little bit more algebra at the beginning. They actually, I think, they busted out the product rule. Okay? Again, you don't have to do that. You get 2 points for just being able to get this right here. You get 2 points right there. Okay? And then you get a 3rd point for just explaining it. There's your minimum 3. Okay? Pretty easy to do. They made a statement here that is concave down, and they explained it because the second derivative is negative, which is exactly what I wrote in red over here. Okay? Again, very doable. It's analytical. The last problem was more graphical. So you want to be flexible with both. Okay? Let me try to find another one here. Let's do that's analytical, maybe something graphical for you guys. Okay, so let's do this one here. 2008, Form B, Part A. Okay, so get familiar with what you're given. The graph here represents G prime. Okay, and then they're asking us to find the x-coordinate of all points of inflection to the graph of G. So if I want to find the point of inflection for G, I have to go all the way to the second derivative. Right? So I have to go all the way to the second derivative. So in order to find a point of inflection, G double prime has to change signs. Okay? But if you take a look at this picture, we don't have G double prime. So if you go back to the beginning, G double prime changing signs is the same thing as G prime changing directions. Okay? Make sure that you understand that part. I got lost. Oh yeah, we're right here. So this is the same thing as G prime changing directions. Okay? So if you take a look at the picture here, where does G prime change directions? Press play when you're ready. Okay? There should be 2 inflection points, okay? So we're going to say at x equals 1 and x equals 4. Okay? That's the moment where you stop increasing, start decreasing, and vice versa. So again, how do you justify that, right? So we know at x equals 1 and x equals 4, G has a point of inflection. AP readers will know what that means. Since G prime changes directions. That's really all you need to write down. Since G prime changes directions. Okay. But the most pivotal point is understanding that these two are equivalent. Okay? Not a lot of work to be shown. It's a lot of analysis. That's why they call it graph analysis, right? So, I'll do one more. Okay, 2007. I'll do part C. Okay? So part C here, they're asking us where F, and I'll write it down, where F is concave up and where F is also have a positive slope. Okay? Okay, so first off, F having a positive slope. You have to remember that slope just means derivative. So you want the derivative to be positive. That's really what it's saying. Okay? So we're trying to find out where F is concave up and where the derivative is positive at the same time. Okay? So here's the issue. If you take a look at the graph, the graph represents f prime. So this is all about translating your language, right? F is concave up. What the heck does that mean in terms of f prime? So look back if you need to, but slowly try to pull away from that. F is concave up is the same as saying f prime is increasing. Okay, and this is already in our language, f prime. So this is what we're looking for. So let's start off with the direction. Where is f prime increasing? Okay, I'm going to go ahead and highlight here so it's a little bit easier for you to see. F starts to increase from -5 to -4, and then it starts to decrease, and then from -1 to 2, it increases. I should say f prime increases, okay? Okay, so that's pretty much my, I'll color coordinate here so you guys can see. That's my yellow highlight. Now, my green highlight. Where f prime is positive, that just means where f prime is above the x-axis. So here I have from -5 to 3, and from 1 to 4. So the key word here is and. Where is f concave up and have a positive slope? So where do they both overlap here? Where does the yellow meet the green? So I noticed that they overlap from -5 to 4 and also from 1 to 2. And how do I know that? Since, and this is where you really justify, since f prime is increasing and f prime is, I should say f prime is greater than 0. Boom. Again, not a lot of work to be shown. This part up here is really the big chunk. You understanding how to translate what they're asking for. Okay, you had a lot of practice with that in the first semester, so use this as an opportunity to kind of refresh, okay? Do the rest. If you get stuck, let me know.